You know, we're surrounded by numbers every single day. But have you ever stopped to think that they might have hidden properties? It's almost like they have their own secret language. Well, today, we're going to learn how to speak that language and decode some of their deepest secrets.
So let's kick things off with a little puzzle. Take a look at this number on your screen. Now, without grabbing a calculator, could you tell me if it's divisible by 3? I mean, it looks like a ton of work, right? Well, what if I told you there's a simple trick, a secret code, that makes this ridiculously easy? Stick with me and you'll know the answer in no time.
All right, our first stop on this journey, we're going to crack what I like to call the divisibility code. These are just a bunch of simple rules that let you see if one number can be divided by another without any messy leftovers. Think of them as the first set of keys to unlocking how numbers really work.
So, what's divisibility all about, really? It's actually super simple. If you can divide one number by another and the answer is a nice, clean, whole number, no fractions, no decimals, then it's divisible. For example, 28 divided by 4 is 7. That's a whole number. So yeah, 28 is divisible by 4. See? Easy.
Okay, here it is, our secret codebook. This table is packed with shortcuts, so you might want to pause here and just take it all in. Some are pretty obvious, right? A number's divisible by 2 if it's even, it's divisible by 5 if it ends in a 0 or a 5, but my absolute favorite is the rule for 3. If you add up all the digits and that sum is divisible by 3, the whole number is 2. Now that's the key to our big puzzle from the start.
And you know what's really cool? These rules can actually team up. To check if a number is divisible by 6, you don't even need a new rule. You just ask two questions we already know the answer to. Is it divisible by 2? And is it divisible by 3? If you get a yes for both, then it's divisible by 6. Simple as that.
Okay, let's put this code to the test, shall we? How about the number 801? Is it divisible by 9? Well, the rule for 9 is just like the one for 3. We just add up the digits. So 8 plus 0 plus 1, that's 9. And is 9 divisible by 9? Of course it is. So yes, 801 is definitely divisible by 9.
Let's do one more, a little bigger this time. 2,763. Let's add them up. 2 plus 7 is 9, plus 6 is 15, plus 3 is 18. Now, is 18 divisible by 9? Yep, it's 2. So that means the whole huge number, 2,763, is 2. See how powerful these little tricks are? Pretty amazing, right?
So now that we know how to check for divisibility, we can get into the really fun stuff, taking numbers apart and putting them back together again. And that brings us to two fundamental ideas: factors and multiples.
First up, let's talk about factors. The best way to think about them? They're basically a number's Lego bricks. They're all the whole numbers that you can multiply together to get to that number, with no bits left over. Let me show you what I mean.
Let's take the number 20, for example. What pairs of numbers can you multiply to get 20? Well, there's 1 times 20, there's 2 times 10, and there's 4 times 5. So all those numbers, 1, 2, 4, 5, 10, and 20, are its factors. They're its core components.
And on the flip side of factors, we've got multiples. If factors are all about breaking a number down into its parts, multiples are all about building up. You just take a number and see how big it can get by multiplying it by 1, then 2, then 3, and so on. Just think of the number 4. What are its multiples? Well, they're just its times tables. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12, and it just keeps going. These are all the numbers that 4 can divide into perfectly.
Okay, so numbers have factors for breaking down and multiples for building up. But things get really interesting when we start comparing two different numbers. It's like finding their shared DNA, their common ground. And we have two amazing tools for this, the HCF and the LCM.
First, let's talk about the highest common factor, or HCF for short. It's exactly what it sounds like. You look at all the factors for two different numbers and you find the single biggest one they both have in common.
Let's make this super clear. Imagine you've got the numbers 16 and 20. The factors of 16 are 1, 2, 4, 8, and 16. The factors of 20 are 1, 2, 4, 5, 10, and 20. So what's the biggest number that's on both of those lists? It's 4. So the HCF of 16 and 20 is 4.
And then we have its partner, the lowest common multiple, or LCM. Again, the name gives it all away. This time, you list out the multiples of two numbers, and you look for the smallest, the very first one they share.
Let's try it with 8 and 12. Okay, the multiples of 8 are 8, 16, 24, 32. Let's stop there. Now for 12. The multiples of 12 are 12, 24. Oh, wait, there it is. The first number to appear on both lists is 24. That's our LCM.
So this is the key difference, right? It's a great way to think about it. HCF is all about breaking down numbers to find their biggest shared piece, and LCM is all about building up with numbers to find their first shared destination. They're really just two sides of the same coin.
We've been talking about factors and building blocks, but now we're getting to the most fundamental, most important building blocks of them all. We're talking about prime numbers. These are like the source code of arithmetic itself, and they're the secret behind everything from online security to, well, all of math.
So what exactly is a prime number? It's a number that's so basic it only has two factors, 1 and itself. That's it. Think about numbers like 2, 3, 5, 7, 11. You can't break them down any further. They really are the fundamental atoms that all other numbers are built from.
But hang on, what about the number 1? This one's a bit of a special case. It's actually neither prime nor composite. And why is that? Because to be prime, you need exactly two factors. The number 1 only has one factor, itself, so it gets its own special category. It's just 1. And here is the truly mind-blowing part. Every other whole number that isn't prime can be broken down into its own unique code of prime factors. This is called prime factorization, and it's like finding the unique DNA sequence for that number. No two numbers share the same prime code.
So how do we find this code? A factor tree is a really cool way to visualize it. Let's try it with 350. We can start by splitting it into 10 and 35. Now neither of those is prime, so we keep going. 10 breaks down into 2 and 5, bingo, both prime. And 35 breaks down into 5 and 7, more primes. So the unique prime code for 350 is 2 times 5 times 5 times 7.
Okay, to wrap things up, I've got a final puzzle for you to chew on, using everything we've learned. Here it is. There's a 2-digit number, and both of its digits are the same. When you multiply those two identical digits together, the result is not a composite number. So what is the original number? Now remember what not composite means. It could be prime, or it could be that special number 1. I'll leave you to decode that one on your own.